Hello and welcome to my channel. Today I'm going to give you an update on the 12 volt distribution system in my car. Welcome back and thanks for being here. My name is Scott, and if you've been watching for a while, then you may have already seen my not so simple 12 volt distribution video. And in that video, it was accurate at the time. I had this whole panel out and on a bench and gave you a walkthrough, but I've made sweeping changes since then. So this is kind of a replacement video for that. So let's get into it. I am going to show you I can't call this a schematic, most people would, but it's really more of a simplified block diagram, or maybe a functional block diagram. It's not showing wire for wire, it is just showing 12 volt current flow. And this looks kind of sophisticated, and maybe it is, but once I show it to you in the car, it'll look a lot more convoluted. So I'll refer you back to this schematic, I think, once or twice throughout the video. So, all right, here, check this out. So, as with the vast majority of automotive systems out there, everything starts at the 12 volt starter battery, of course, which is in the engine bay. And then it's charged by the alternator when the car is running. I have a 100 amp circuit breaker sitting right at the positive terminal of my starter battery, and it can't get much closer to the positive terminal than that. I think my cable there is about 1 inch, which is almost as short as I could make it and still get terminal lugs onto that thing. The 100 amps, believe it or not, that really is all I need for what I have going on back here, and I'll explain that in just a minute. From there, the 12 volts travels to the back of the car through 14 feet of 4-gauge oxygen-free copper cable and comes right to here. This terminal right here of this 12 volt relay. This is a 200 amp relay. I'm never going to need 200 amps, but I wanted to make sure that it would take an awful lot for it to fail. So 12 volts comes and sits right here and waits for a signal to turn on this relay. So what turns on the relay? Well, I can't see it, but I think you might be able to spot it. There is another wire coming off of it, which then comes over here to the input side of this APO3, which is an automatic power off. And what that does is it turns off power to appliances when the voltage of the battery falls below a certain level. I have mine set to 12.7 volts. Most car batteries, when they are at rest, will eventually come down to about 12.6 volts and sit there, and that's where they normally will rest. So what that means, for the most part, is that this APO3 remains energized while the engine is running and the alternator is outputting charging voltage, and for approximately 20 minutes after I shut the engine off. So when right now everything's turned off, so if I were to start the car, it takes about 5 seconds or so, but this will eventually detect charging voltage that is greater than 12.7 volts, and then it will output to the relay and energize the relay. Then the relay will energize and send voltage here to this fuse. Now this fuse panel, if you take a really good look, recognize that it is split into two halves. And so this relay is only feeding this 140 amp fuse, and the output of this fuse goes back this way and then around to the other side of the panel and feeds my subwoofer amplifier. So the sub amplifier only works or is only turned on while the engine is running. And I did that on purpose to make sure that music didn't accidentally drain my battery. Now there's another output from the relay here. If you look at it, it's kind of a tight loop, but it loops back around here and comes to feed this fuse strip here. There is here this pair of 30 amp fuses. They are parallel. Each of these circuits is allowed to be 30 amps, but I need more than that to feed what this feeds. So I have paralleled two 30 amp fuses. They parallel to create an output here. So this output, that goes to the DC to DC converter that is used to charge my lithium battery. That's right, I've got a lithium battery in the car. It is a secondary battery, an alternative battery, what else? Auxiliary battery, house battery, whatever you want to call it. It's a secondary battery in the car, and that's a separate video altogether. These other two fuses, the 7.5 amp fuse goes to a battery warmer that's for the lithium battery. And believe it or not, the lithium battery actually powers its own battery warmer. But then when the car is running, I want the car to power the battery warmer. And the battery warmer turns off after the battery has reached a preset temperature. And so that's what this circuit is for. And then the 10 amp circuit is for my trailer lighting controller, which is buried under this fender area here. It's out of sight and I almost never need to access it. I reset it from time to time, but I can do that with the circuit breaker at the front of the car. No big deal. And then, as I said, I've got plenty of room for growth. Let's see, there is another branch coming off of this output, and that goes, it wraps around here and comes to this single fuse on this panel here for the LC2i. Again, that is stereo stuff, and I'm not talking about the stereo in this video, but that's what this single line here is for. So how is all of my ham radio equipment powered? My amateur radio equipment, whatever you want to call it. Well, that's where this other path comes through. It's actually pinching under here. I'll talk about this in a second. This red wire right here comes to another 200 amp relay. And so it comes and sits right here and waits for a signal to turn it on. Now, the way that is energized, you can see there is a wire running off this way and toward the front of the car. That goes to a small switch under my parking brake lever. So when I flip on that switch, this relay energizes, and then its output comes this way, it wraps around here to this other 40 amp fuse, which then powers this voltage regulator. This is it's called a super booster by N8XJK. And what this does is it regulates its output voltage to a voltage of my choosing. It's made to extend the life of a battery. Say you're working your ham radios at a field day site or something, and you're trying to get the most out of the batteries you can. A lot of transceivers, once their input voltage drops below a certain level, they won't work anymore. What this does is it might take the input from a weak battery, maybe as low as 10.5 volts, and it'll regulate it up to a voltage of my choosing. In my case, I've chosen 14.2 volts. So basically, no matter what's being fed into it from the front of the car, it will always output 14.2 volts so that my transceivers have nice, steady, regulated power. It's actually pretty cool. It'll do up to 40 amps, and I can actually take more of these and put them in parallel with each other for more current if I need it to be. 40 amps is sufficient for me. All of my transceivers combined do draw more than 40 amps, but I only ever talk on one at a time. So 40 amps works just fine. And so that output from this voltage regulator, you can see I've got a negative going into this fuse panel here, and then the positive coming to right here. And so basically the way these are set up, I've got negative, negative coming out here, going in here, coming out here, positive, positive coming here, going out here. And so one is for the ID 5100, my VHF UHF transceiver, digital transceiver, and the other is for my FT 891 HF transceiver, which is on the other side of the car. I will show you a video about that here. It'll be linked. Just check it out. It's not quite ready yet. Let's see. The only thing left to discuss in here, 12 volt wise, is I'm only talking about this area right here, not the transceivers, not the stereo equipment over here on the passenger side of the car. I have not talked about this point right here. This looks like a hot mess, but what's going on here is this is the single point ground for all of the equipment that's back here. So everything comes to this point. Here is a ground block, which is basically where the voltage regulator is grounded, and I've got grounds coming from the LC2i, the amplifier, and then they all come here to form a common point, which then comes here and attaches to this ground point. And then this 8-gauge wire right here goes to under my rear seat delete, which if I had a rear seat, it would be going under the seat, and then it's fastened to a seatbelt anchor. The seatbelt anchor, as you can imagine, for legal reasons, it's got to restrain a person. So it is one of the strongest points on the whole car, and is welded directly to the chassis. And so I can't think of too much better of a ground than that. And I have checked continuity. It is a continuous electrical path to the negative terminal of the battery, so it works. So what may I have missed? Let me know if you have questions about my 12-volt system. Check out my lithium battery video as well as the DC to DC charger video. They paint the complete picture of what's going on back here. Have another look at this functional block diagram to see what's going on back here. I have a lot going on. I haven't talked about everything that this setup powers because realistically, the vast majority of what's going on in the car is being powered by the lithium battery. The car itself is only powering my stereo equipment. So when the car is off, the subwoofer part is turned off. Everything else back here is being fed by the lithium battery. So even the 12-volt electrical outlets that are factory in the car, powered by the lithium battery. So the car, the starter battery almost literally is for only starting the car. It'll power the stereo because that's a factory function. It'll power the ventilation if I have the key turned on. But other than that, it starts the car, and the lithium battery can operate completely independent of the car itself. So I think I've done all right as far as setting this up for success. Let me know what you think. Comment below. As always, I appreciate you being here, and I will see you next time. Take care.